In this video, I will be showing you how to work out exercise 16.23, which reads at point A, 4.4 meters from a small source of sound that is emitting uniformly in all directions. The intensity level is 59.0 decibels. Part A reads, what is the intensity of sound A? Which we come down here. So I started off with writing our knowns. Distance is 4.4 meters and the intensity is 59 decibels. Start with the equation beta equals 10 log divided by intensity, or times intensity divided by intensity log. So we put in our knowns into that equation, which gets us 59 decibels divided by 10 log times the intensity divided by 10 to the negative 12 W divided by M squared, which gets us rounded 8. And the intensity equals 8 times 10 to the power of 7, which is rounded up, or which I rounded up, but the actual answer is 7.94 times 10 to the negative 7 W divided by M squared. So part B reads, how far from the source must you go so that the intensity is 1/4 of what it was at A? So we go down here, part B, which I started off with intensity 2 divided by intensity 1 equals R squared 1 divided by R squared 2. So we rearrange that equation. So we get R squared equals 4.4 meters to the square root of 7.94 times negative 7 to the intensity 2, which we use this equation to find out. Intensity 2 equals 7.94 times 10 to the negative 7 divided by 4, since it is a fourth. Since the intensity is 1/4, which gets 1.99 times 10 to the negative 7, which we inputted down here. And when we work out that equation, it's going to equal 8.8 meters, which we got right here. And then part C reads, how far must you go so that the sound level is 1/4 of what it was in A? So we go down here to part C. Part C has us with this equation, beta 2 minus beta 1 equals 10 log times intensity 2 divided by intensity 1. So then we reform the equation so that we have that 1/4 sound level on the B2, which results in us getting the 59.0 decimals divided by 4 minus the 59 decimals equals 10 log times intensity 1 divided by intensity 2. So we work out this equation to eventually arrive at intensity 2, this equation that gets us intensity 2 equals 10.0 to the power of negative 4.43 to the power of negative 4.425 times intensity 1. And then from there, we are able to input the intensity 1, which we'd previously gotten from part A, to make it equal intensity 2 equals 10.0 to the power of negative 4.425 times 7.94 times 10 to the negative 7th power, which gets us I2, which is equal to 3.0 times 10 to the negative 11. And then we arrive back at the previous one of the previous equations. So R2 equals R1 to the square root of intensity 1 divided by intensity 2. We can use that equation to get our R2, but before that, it's going to be R2 equals 4.4 meters to the square root of 7.94 times 10 to the negative 7 divided by 3.0 to the negative 11th power, which gets us 718 meters. And then part D asks us, does the intensity obey the inverse square law? From the answers that we have gotten, yes, it does. Part E reads, does the intensity level obey the inverse square law? And from the answers we've gotten, no, it has not. And that is exercise 16.23.